Welcome to the mathematics session. Let's start with chord and its properties. Then, what is a chord? Here I have drawn a circle. Its center is O. And you can see that in the circle, I have drawn some line segments and I am going to name it like AB, P, Q and CD. You can notice that AB, PQ and CD, for these line segments, the endpoints lies in the circle itself. Now, chord means the line segment whose line segments in the circle itself. You can see that AB, PQ, CD. Here, PQ is slightly different from AB and CD. How it is? Because O, the center of the circle, PQ is passing through the center of the circle, and you know that center of the line segment passing through the center of the circle, we name it as diameter. Also, the diameter is also a chord. So, we can conclude that in a circle, the largest chord is the diameter. This is the first property of the chord. So, here I have drawn the circle. AB is the chord. Here I am going to explain the theorem, what I wrote here. Here is a line segment OC. It starts from the center of the circle. And this line segment OC bisecting the chord AB. Bisecting means it's dividing equally. Then the line segment starting from the center of the circle bisecting the chord, then the line segment will be perpendicular to the chord. That's what the theorem is saying. Now let's move to the proof of the theorem. To prove a theorem, there are 4 parts. The first one is given. We need to identify what are the given things. The second one is to prove. To prove means here we need to identify what is the thing we need to prove. The third one is construction. In construction, there comes the things that helps us to prove the theorem that we are going to construct in the figure. There comes the construction. And the last thing is the most important part of the theorem, that's proof. In a proof, there are 2 things. Inside the proof, we have to write the statement with reason. So in the theorem, for every theorem given, to prove, construction and proof are the 4 important things. Let's start the proof of the theorem. The first step is given. So we are identifying from the figure that here's a circle with center O and the line segment OC bisecting the chord AB. So we are going to write like circle with center O and the chord AB, OC is bisecting AB. OC bisects AB. Then what we can say, bisect means it's dividing equally. Here AC and CB are equal. AC equal to CB. The second step is to prove. Here, what we need to prove? We need to prove OC is perpendicular to AB. Then the third one, construction. Look at the figure. What we can construct here? O is the center. AB is the chord. A and B are some points on the circle. So if I join OB and OA, you can identify that OA and OB are the radius of the circle. So it will be equal. So construction means join OA and OB. These are the radius of the circle. Proof of this theorem. We have to prove OC perpendicular to AB. What is perpendicular? Perpendicular means that these two lines makes an angle of 90 degrees, which means that here angle OCA and angle OCB should be 90 degrees. One more thing you can see from the figure, ACB. ACB is a straight line, and at C you can find an angle of 180 degree. It's called straight angle. So ACB at C is 180 degree. If we prove these two angles, OCA and OCB, are equal, the sum will be 180 by the straight angle. So each one will be 90 degree. So to prove this one, we are going to take the use of congruency. For that, we will consider the two triangles OAC and OBC. Let's start with that. Consider the triangle OAC and triangle OBC. From these two triangles, the first thing, AC and CD, the two sides of this triangle, AC and CD, are equal. We wrote it in the given part. AC equal to CD. The reason is given. In the given part, we mentioned it. Now, what about OA and OB? Clearly the radius. OA equal to OB, radius of the circle. The third side is OC. OC, the side OC is common to both the triangles. So, OC equal to OC, common side. So, what we got from here? We identify the sides. The three sides, the corresponding three sides are equal. So, we will use the rule SSS or side congruency rule to say triangle OAC congruent to triangle OBC. We just prove triangle OAC congruent to triangle OBC. OAC and OBC are congruent. So, we can write angle OCA and angle OCB are equal. Angle OCA equal to angle OCB. What's the reason? Reason is corresponding part of congruent triangle are congruent. Corresponding parts of the congruent triangle are congruent. Angle OCA and angle OCB are the corresponding parts. And from the figure, you can write angle OCA plus angle OCB equal to 180 degree. Reason is straight line or straight angle. OCA and OCB are equal from the previous statement. So I am writing it as angle OCA plus, instead of angle OCB, repeating angle OCA itself, it's 180 degree. OCA plus angle OCA is 2 times angle OCA, 180 degree. So what will be angle OCA? It's 90 degree. So we prove that angle OCA is 90 degree. From this statement, I can write it as angle OCA equal to angle OCB equal to 90 degree. So both of the angles we proved as 90 degree. So clearly the line segment OC perpendicular to the chord AB. Hence the theorem. Thanks.